So 7.3 is kind of like an introduction to what we did in 7.4. They go hand in hand. When we write our answer, we're going to be solving systems of equations again. You want to write them as an ordered triple, just like we talked about at the end of 7.4. So example 1, here we want to use back substitution to solve our system of linear equations. So we always want to start with the one that gives us one variable. Where do you think I'd plug this into? The second equation, perfect, because if we only have one, we can only plug it into an equation with two variables. So we're going to plug it into our z there. So we have y plus 4 times 2 equals 7. So y plus 8 equals 7. What would we do next? Subtract 8. So y equals negative 1. So now that I found what y is equal to, what could I do next? Awesome. We're going to plug z into z and y into y. So we've got x minus 2 times negative 1 plus 3 times 2 equals 9. So x, this turns into plus 2 plus 6 equals 9. So x plus 8 equals 9. Subtract 8 on both sides, so what does x equal? 1. How would we write our answer? What comes first? The x. So 1, then y would be negative 1 and 2, an ordered triple. Right. In example 1 on the next page, so different example 1, we want to show that the ordered triple is a solution of the system. To show that it's a solution, we're going to plug them in. I want to plug 1 into the x, 0 into the y, and 2 into the z. Here it kind of cheated because it wrote it above it for us, but it's not going to tell you x, y, z. You just have to know first one's your x, second one's your y, third one's your z. So we need to plug it into all 3 of our equations and see if it makes sense. The equations have to be true in all 3 of them. So I have 1 minus 3 times 0 plus z would be 2 equals 3. When we work this out, we get 1. Negative 3 times 0 would just be 0, so that goes away. 1 plus 2 equals 3. So 3 equals 3. Is this true? 3. Yes, so it works out in the first one. Let's test the second one. So we have 2 times 1 plus 0 minus 5 times 2 equals negative 8. So 2, 0 is just going to go away, minus 10 equals negative 8. Negative 8 equals negative 8. Is this true? Yep, so it works in the second. Let's test the third. So 1 minus 0 plus 3 times 2 equals 7. We've got 1 plus 6 equals 7, so 7 equals 7. Is this true? Yes. So then, yes, it is a solution. So you have to test all 3. It could work in the first 2 and not in the third, so you have to check all 3. If it doesn't work in 1 out of these 3, then it would not be a solution. So example 2, we want to solve the system using back substitution. Again, ignore the arrows. It kind of cheated and started it a little bit for us. But what would we do first? Awesome. We're going to use substitution, plug in z into the second equation. So make sure you plug it into the z. We have y plus 2 times 8 equals 6. So y plus 16 equals 6. Subtract 16 on both sides. So y equals negative 10. What would we do next? Z and y? Yes. So 8 is going to go into z. Negative 10 is going to go into y. So we have 2x minus negative 10 plus 5 times 8 equals 24. So 2x plus 10 plus 40 equals 24. 2x plus 50 equals 24. What do we do next? Subtract 50. So 2x equals, what's 24 minus 50? negative 26, and then divide by 2. So x equals negative 13, perfect. So our x is negative 13, our y is negative 10, and z is 8. So that would be our answer. With these questions and with the ones that we did in 7.4, just be super careful with the math. If you make a mistake with the sign in the beginning of the question, it's going to throw off the rest of it. So you could make a mistake on finding the first variable, and then the rest are going to be wrong after that. So just be super, super careful. And just like we did in example 1 on the last slide, you can always check your work. Plug back in your x, y, and z and see if it's true in each equation. This page just describes the process of how we solve with 3 variables and three equations. So we did it in 7.4. We're going to practice a couple more here. So looking at example 2, I'm going to solve the system of linear equations. Let's label them. Which variable do you want to eliminate? X seems like a good one. A lot of the coefficients are 1 here, and the other one's 2, so it's a good choice. Which 2 equations do you want to combine first? 1 and 2, great choice. So 1 is x minus 2y plus 3z is equal to 9, and 2 is negative x plus 3y plus z equals negative 2. So the x's cancel. Then we combine our like terms, so we get y plus 4z is equal to 7. Now we have to do this step twice. So let's pick another 2 equations and combine them together. Which 2 do you want to pick next? Two and 3. That's what I would have picked. 2 and 3. So we've got negative x plus 3y plus z is equal to negative 2, and 2x minus 5y plus 5z is equal to 17. Now we have to eliminate the x's again here. You have to pick the same variable. Do the x's eliminate right away? No. We need them to be the same number but opposite. So how could I change that negative x to be a negative 2x? That would get me to cancel. Multiply the whole equation by what? 2. So I'm going to multiply everything in my equation by 2. If you want to write it out for each term, everything gets multiplied by 2. Don't forget the right side of your equal sign. A lot of people forget that. Remember, if you make a mistake early on, it's going to throw off all of your answers. So just be careful. So we have negative 2x plus 6y plus 2z is equal to negative 4. So let's combine these together now. X's will now cancel. 6y minus 5y would be y, plus 7z is equal to 13. What would we do next? Awesome. We're going to take these 2 equations now and combine them together. So y plus 4z is equal to 7, and y plus 7z is equal to 13. Which variable do you want to eliminate here? Y. Great choice. But we don't have the same number but opposites, so how can we make them the same but opposites? Multiply negative 1 to which equation? So the first one. It doesn't matter. You could have picked either one. But make sure you multiply everything in that equation by negative 1. So we have negative y minus 4z is equal to negative 7 now. Now we can combine these 2 together. The y's cancel. What's negative 4z plus 7z? 3z. And then negative 7 plus 13? 6. Awesome. And then we can divide by 3. So z equals 2. What can we do next?
Put z into the equations that you created.
Awesome. I'm going to put z into one of these two highlighted equations. Because I only have one variable, so I can only plug it into an equation with two variables. Which one do you want to plug it into, the left or the right? It doesn't matter. You could pick either one. I like the left one because the numbers are smaller. But if you plugged it into the right, you'd get the same answer. So we have y is equal to, y plus 4 times 2 equals 7. So we just plug 2 into the z. So y plus 8 equals 7. Subtract 8 on both sides. So y is equal to -1. So we've got 2 answers now. What can we do to find the third? So we're going to plug in y and z where? Into one of the original equations. The second one's a good choice. You can plug it into any one. It does not matter. So we've got -x plus 3 times y is -1 plus z is 2 equals -2. Bless you. So -x minus 3 plus 2 equals -2. -x minus 1 equals -2. We can add 1 to both sides. So -x equals -1. What's the last step? Divide by -1. Perfect. So x equals 1. How would we write our answer? An ordered triple. What comes first? So 1 comma -1 comma 2. Perfect. So just like we did in the last one, we want to pick 2 equations. We'll pick a variable first, then we're going to pick 2 equations and eliminate that variable and do it twice. Which variable do you want to eliminate? This one's not as easy as the last ones where we could clearly see what's best, but pick any one. If there's not one that stands out to you that all the coefficients are the same, pick any variable that you like. Which one do you want to pick here? I think x is a good choice. X is a nice choice because we have a variable that has a coefficient as 1, so the first equation is going to be the easiest one to work with because we can manipulate it however we want. So which 2 equations do you want to combine together first? 1 and 2. So 1 is x plus y plus 3z is equal to 7. And 2 is 2x minus 4y plus z is equal to 7. Do our x's cancel? Nope. No. So here we have to multiply by some number to get them to cancel. What would we have to multiply our first equation by? -2, because we need it to be the same number but opposite. So since we already have a +2, we're going to multiply by -2 to make it the same but opposite. So we're multiplying everything in our first equation by -2. A common mistake that people will make is they'll forget the right side of the equal sign. So don't forget, we're multiplying everything by -2. So -2x minus 2y minus 6z is equal to -14. There's a lot of little math going on here. You guys can multiply by -2, but just be careful with the math going on. Be careful with the signs. If you make a mistake with one of your signs in the first step here, it's going to throw everything off. You're going to be dealing with ugly fractions, and it's not going to work out right. So just be careful with the math. Let's combine our 2 new equations now. Do the x's cancel now? Yes. Then -2y minus 4y would be -6y. -6z plus z would be -5z. And then that's equal to -7. What should we do next? So remember, we have to do this step twice. I eliminated x in equation 1 and 2, so let's pick 2 other equations. We have to eliminate x again. Which two equations do you want to work with here? 1 and 3. Perfect. So 1 and 3. 1 is x plus y plus 3z is equal to 7, and 3 is 3x plus 5y minus 4z is equal to negative 6. So what we have to multiply by the first equation to get the x's to cancel? Negative 3, perfect. So we get negative 3x minus 3y minus 9z is equal to negative 21. So now let's combine these together. X's cancel now. We're left with 2y minus 13z is equal to negative 27. What should we do next? We could cancel out the y. Let's pick two equations here. Or we don't pick. We're going to take our two equations, the two answers that we just found, and we're going to combine these together. So we have negative 6y minus 5z is equal to negative 7, and 2y minus 13z is equal to negative 27. Now, Duvie said we want to cancel out the y. Can they cancel right away? No. What do we need to multiply by to get them to cancel? 3. So I'm going to multiply everything in my second equation by 3. I'm going to rewrite it. I'll rewrite it next to it over here. So times 3, and times 3. So we get 6y minus 39z is equal to, what's 27 times 3? Negative 81. And negative 6y, I'm rewriting the first one here just to keep them on top of each other, minus 5z is equal to negative 7. So now our y's cancel. We have negative 44z, and it's equal to negative 88. What should we do next? Divide by negative 44. What's negative 88 divided by negative 44? 2. Awesome. I love when it works out to be a nice small number. I'm dealing with big numbers. But notice here, if you made a mistake with the signs and or added wrong and you ended up with like 43 and you divide by 43, 88 divided by 43 is an ugly fraction. So be super careful with the math. Do not make a mistake. What should we do next? So we can plug it into either one of these two equations that only have two variables. Can't plug it into the original one yet. I like the left one better so the numbers look a little bit smaller. So I'm going to plug it in here. So negative 6y minus 5 times 2 equals negative 7. So negative 6y minus 10 equals negative 7. We're going to add 10 to both sides. Negative 6y is equal to 3. Divide by negative 6. So y equals what? Negative 1/2. Perfect. What should we do next? Now that we have two answers, we can plug it into one of our original 3 equations. I think number 2 would be the easiest because looking at the fraction that we just found with y equals 1/2, if I multiply it by an even number, it's going to work out to be a whole number. So 2, I think, would be the easiest. If you want to plug it into 1 or 3, that's fine too. If you do the math correctly, you'll end up with the same answer. So I'm going to plug it into 2. So we have 2 times x minus 4 times negative 1/2 plus z, so plus 2, equals 7. So 2x, what's negative 4 times negative 1/2? 4 over 2, which is 2. So plus 2 equals 7. We get 2x plus 4 equals 7. Subtract 4. 2x equals 3. Divide by 2, x equals 3 halves. So now let's write our answer as an ordered triple. We've got 3 halves, -1 half, and 2. So again, here we're going to solve. Let's label everything. Which variable do you want to eliminate first? Sure, we could do x's. So which 2 equations do you want to work with first? We'll do the first and third, and then we could do the first and second. So let's do 1 and 3. And since I heard 1 and 2, I'll do that one next, because we have to do this step twice anyways. So equation 1 is x minus 3y plus z equals 1. And equation 3 is x plus 2y minus 3z is equal to -1. Do the x's cancel? No. How do we get them to cancel? Make one of the equations negative. So we're going to multiply the first equation by -1. So I'm just going to flip all the signs of everything here. So if you want to rewrite it, you can. I just multiplied everything by a negative. So I flipped all the signs. Now we can combine them. The x's will now cancel. 3y plus 2y is 5y. -z minus 3z would be -4z. And -1 minus 1 would be -2. All right, let's do that again. We said let's combine 1 and 2 next. So we have x minus 3y plus z equals 1, and 2x minus y minus 2z is equal to 2. Do the x's cancel here? No. What do we have to multiply to get them to cancel? -2. So I'm going to multiply by everything, or multiply everything by -2. So -2x plus 6y minus 2z is equal to -2. Let's combine these together now. X's will now cancel. We have 5y minus 4z is equal to 0. What do we do next? Combine these 2 equations now. So we have 5y minus 4z is equal to -2, and 5y minus 4z is equal to 0. What do you want to cancel here? Sure, let's cancel y. What do we need to multiply by to get y to cancel? -1. So let's flip the signs of everything. You could do it in the first or the second equation. I'll do it in the first one here. Now our y's cancel. What's 4z plus minus 4z? What happens to the z's? They cancel. So what are we left with on the left side? On the left side. If everything cancels, what are we left with on the left side of our equal sign? Nothing, or 0. And then what's 2 plus 0? 2. Does 0 equal 2? No. So our answer here would be no solution. Now be careful, because a common mistake that people will make is that they'll end up getting x equals 0, and they'll think no solution. 0 is a number. X can equal 0, y can equal 0, z can equal 0. They could all equal 0. But 0 can't equal 2. So just keep that in mind. X can equal 0. This is possible. But 0 cannot equal 2. If you get 0 equals a number that's not 0, your answer is no solution. So this is an inconsistent system because it gives us no solution.